And perfect. Now we have recording. Wonderful. And in the BPI, we have a number of initiatives, essentially to bring together talent, infrastructure, and state-of-the-art research in a very innovative ecosystem. And some of the activities that we are involved in are shown on the right. That means pretty much to look into deep science discoveries, as well as scale up innovation, and also supporting global partnerships. And in the BioProducts Institute, we have every year a program that hires interns to work with us, with the BPI staff members. The interns are usually recent graduates. And this year, we have the fortune to work with 4 of them. We have here Daishi Hirata, who is an application engineer, Annie Markarainen, technical business analyst, Bryden Pelham, technical business analyst as well, and likewise Riva Siddiqui. And you can see in the bottom their backgrounds, and they have been working with BPI in many different initiatives. Essentially, we meet every day, and then once a week, they report a little bit of their findings in different areas. And it has been a really big pleasure to work with these smart, intelligent, energetic interns that will provide us a little bit of their insights in one of the many, many topics they have been working on. So what they will present today is just a little fraction of what they have learned during the recent months. So welcome you all to this webinar. I hope you enjoy. And now I think we're ready to listen to our interns. So now the floor goes to you.
Thank you, Orlando. And thank you to everyone that has taken the time to attend our webinar today. I'm sure everyone heard the Zoom notification, but just to let everyone know, the webinar is being recorded. But before we begin, we also want to acknowledge that as members of UBC, we are participating in this webinar from the traditional, ancestral, and unceded territories of the Musqueam, Squamish, Tsolo, Tsleil-Waututh, and Syilx people. And as Daichi is actually joining us from Calgary, we also would like to take this opportunity to acknowledge the traditional territories of Treaty 7 and the Métis Nation of Alberta, Region 3. We also want to acknowledge that this project was made possible through funding provided by the BC Ministry of Forests, Lands, Natural Resource Operations, and Rural Development. And we also wanted to thank the entire team at BPI for assisting us throughout our research. So as Orlando kind of touched on, Annie, Daichi, Riva, and myself are actually all recent graduates of UBC, and we're just coming up on the end of our 6-month contract here at BPI. As a group, we have a fairly multidisciplinary background, which includes public policy, chemical and biological engineering, sociology and biology. And for the past 6 weeks or so, we've been putting together some research on bio-based materials and housing within remote British Columbia. And so we thought this would be a pretty good opportunity to give an overview of some of our findings. So to give you an idea of what we'll be going over for the next 40 minutes or so, I'll be providing some context into why there's a need to rethink remote housing and how bio-based housing might alleviate some of the challenges associated with remote housing in BC. We'll take a look at some of the current bio-based housing technologies, with Riva examining additive manufacturing and Daichi looking into prefabricated or modular housing. And then to conclude, Annie will be identifying some of the gaps in policy, knowledge, and research that might be preventing some more of the widespread adoption of bio-based construction materials and technologies. So this is a picture of a house in Yakulit First Nation, which is located near Tofino on Vancouver Island. From the picture, it looks like there's some pretty clear deterioration. It might not be sufficiently insulated, and there's most likely some mold growth. In this case, the house was actually built in the 1980s or late 1970s, but the materials used were not ideal for kind of a coastal rainforest environment. There was also confusion over ownership of the property, and this led to a lack of upkeep, and in general, a lack of funding and confusion over the enforcement of building codes in the First Nation meant that many of the houses built during this time were likely not built to code. And without enough funding to properly demolish the property, it will likely remain where it is and continue to deteriorate. So why do we need to rethink housing in remote BC? We can kind of imagine some of the challenges that would come from building a house in a remote area. Some of the questions you might have would be how would you get supplies to the site from so far away, and would you even have access through the winter? What do you do with construction waste? Or how do you affordably build a house that will also adapt to climate change? In general, how we build and live within the built environment is starting to shift, and this shift is in response to a number of different factors, particularly that conventionally built homes are just simply not really a long-term sustainable option. And this is especially relevant in remote communities across BC, as the standard housing formula doesn't necessarily translate well against some of the extreme variation in topography, climate, and distance across the province. So recognizing the challenges, what are some of the current consequences of constructing remote housing? In general, construction, demolition, and building operations are significant emitters of CO2. But on top of emissions, housing and construction generate a massive amount of waste. Within BC and remote regions of the province, we have a very difficult time managing this waste. As we can see in the picture to the right, residents in communities, in some cases, resort to open dumping. And this is obviously an eyesore, but it can have some pretty severe environmental and human health consequences, especially when done near housing or water sources. Another side effect of waste mismanagement is that waste is often burned, and this carries its own environmental and health risks as well, especially when the waste contains toxic or hazardous components. Houses in remote communities are frequently deteriorating as well, and often have higher levels of mold and airborne contaminants. And this is because the materials are often not appropriate for the climate, but it's also exacerbated by overcrowding and a lack of housing supply in general. And this could be in part due to difficulties in funding housing projects, higher costs, and a lack of skilled building professionals that are trained in sustainable housing within those regions. So after identifying these challenges, the question that we wanted to ask was, how can bio-based materials alleviate some of the social and environmental challenges associated with construction, carbon emissions, and waste? Given the challenges that I mentioned, there can be several benefits to using bio-based materials in housing construction. These can kind of broadly be broken down into improvements to human health, overall waste reduction, and minimized carbon emissions. There isn't a ton of research necessarily that's been done on how building materials affect our health, but there are some fairly interesting studies that suggest that materials used in our homes do have a significant effect both on a person's physical and psychological health. For example, using natural products has been found to enhance indoor environmental quality, which can then improve the ability to recover from physical and psychological stresses, and that reduces sickness and can increase productivity. There are also several bio-based materials like bio-based paints, asphalt, and concrete that can reduce toxic components from the products. And products like formaldehyde-free composites can improve air quality in homes. So moving forward, the ultimate end goal of bio-based housing would be the aim of moving towards a more circular housing system. And bioproducts could effectively reduce the overall amount of waste, or even ideally completely eliminate waste. And then if sorted properly, construction and demolition waste can be repurposed and reused. And if bio-based products are used more regularly in housing, it will be easier to use construction and demolition waste as a feedstock in the future. Finally, bio-based materials overall have lower environmental impacts than conventional materials, and they sequester carbon. And with more research, we'll be able to further identify the strengths of bio-based housing compared to conventional homes. So given these benefits, Riva will take a look at the current technologies that are being used in additive manufacturing, as well as some of the potential benefits and drawbacks.
Thanks, Braden. So in this section of the presentation, I'll be going over 3D printing, or formerly known as additive manufacturing, as a potential solution to help alleviate some of the housing issues Braden highlighted earlier. Many of you might be wondering what the picture I have here in the background is. Well, it's a rendering of a project that's planned to be completed in British Columbia by a company called 20 Additive Manufacturing in partnership with World Housing. The project is a multi-family compound that's to be built in Nelson, British Columbia with a local engineering firm. And it's to be built to help alleviate homelessness in Canada and allow British Columbia to serve as a gateway for this innovative field. And now, without further ado, let's get into the benefits, industry opportunities, and applications of additive manufacturing. So the question is, what exactly is 3D printing in construction? Well, 3D printing in construction, also known as additive construction, is a building method that's a layer by layer construction process that uses specialized concrete composites. Two of the major advantages of using printing technologies is the potential for reducing cradle to grave process stressors and providing customized housing solutions based on community needs in different environments. Just on this slide here, you can see the potential of this technology within Canada with its first permitted 3D printed home right here, which was built in Proctor, British Columbia, and it's called Fibonacci House. From this pivotal first project, the goal is to expand and advance this technology into the next phase, which encompasses building larger homes, like the community we saw in the previous slide. But because Fibonacci House was primarily built using concrete, which is a heavy pollutant that limits the circularity of 3D printed structures, there lies an opportunity here to improve additive construction by using more sustainable composites. To illustrate the opportunity of using sustainable composites, I'm going to play a short video that demonstrates the use of sustainable materials deployed in a 3D printing project. So the house that we just saw being completed in the video is called Gaia and was built completely out of biodegradable materials. The video here is a great example of the promise that bio-based materials hold for reducing pollutive activities. Even if we don't use fully sustainable composites, additive construction technology, as in the printer itself, has numerous benefits. So for example, printing can reduce design time by up to 60%. And it can also significantly reduce the costs associated with building by between 10 to 50%. Other benefits of this novel technology include a reduction in labor cost and skills requirement. We also see a reduction in material consumption since there's no excess materials being produced and we're only making products that are specific to the project being built. And another benefit is that there's also a reduction in logistical demand since we are minimizing the supply chain. A few additional interesting benefits I've included here is that 3D printing can also increase job desirability since we're creating more professional roles by adding this technology to the field. The 3D printing technology is also more adaptable since anyone with a computer-based background can adopt it and learn it. The last point I'm going to raise here is that it also increases the safety of site safety, since there's a reduction in on-site accidents because there's fewer individuals on the building site, as well as fewer human errors. But even with all these benefits, they're largely related to the printer itself. So to further improve the sustainability of 3D printing, we have to look at improving the composites we use as digital ink. The primary material we use in 3D printing is actually concrete, which is also the most used construction material in the world for 6 major reasons. It's cheap, durable, strong, fire resistant, easily accessible, and customizable. And for these exact reasons, it's also commonly used in 3D printers. But the main difference is that the requirements are of the concrete composite used in a printer is that it's different from standard self-compacting concrete, and the material requirement the material properties are also different to make these structures safer. And in order to make this method more sustainable, using bio-based supplementary cementitious materials, or SCMs for short, instead of original Portland cement, can also improve the environmental impact 3D printed structures have. Additionally, there's also an opportunity here to completely replace synthetic composites with fully bio-based composites, as we saw in the video of Gaia House. Additives that we can use for replacing cementitious components include agricultural residue, industrial byproducts, and construction waste. By using plant and vegetable fibers, plant and agricultural fibers, it is preferred because of British Columbia's diversity, and also because it's easier to dispose of than industrial residues and construction waste. When we source local biomass from waste such as forestry and agriculture, we're also improving the waste management strategies of local communities and decreasing transport-related pollutions, as well as building a new economy in these regions. But just like any novel technology, further research is necessary to better understand the rheology, cost, property, and infrastructural limitations related to sustainable inks. After exploring some of the benefits, I'd like to summarize the opportunities of growth we see within additive manufacturing. The first area of opportunity is, as mentioned, sustainable digital inks to improve structural circularity, since concrete processing is highly pollutive and disposal is difficult. The second area is the impact of automation, because additive manufacturing introduces higher skilled jobs, but there is a need to find a balance between the ones we might lose. The third area is the requirement of new infrastructure to sort and process materials for sustainable inks in remote locations to empower these communities. Fourth, additive manufacturing also presents an interface to improve job skills through knowledge interface and awareness of new technologies to locally operate, innovate, and maintain the technologies in remote regions. Lastly, due to the novelty of additive manufacturing and construction, more comprehensive life cycle and cost analysis are also needed so that we can better understand the impacts and durability of supporting the equipment, maintenance, and ongoing expenses of projects. Although there's still a few areas that still need to be further understood, I'd like to end this section by highlighting the versatile applications of 3D printing technologies with a few examples, with a few local and international examples of projects. The first project that you see on the left here, the top left corner, is a 3D printed project plan using biomass from a company called FP Innovations in partnership with local Indigenous communities and the provincial government of BC. The project is still in its planning phase, but it's a great example of how BC is setting the stage and realizing the potential for this innovative technology. The second project in the top right corner over here is more recent and was announced a few weeks ago by a company called 20 Additive Manufacturing to help alleviate the housing loss felt by people of Merritt, British Columbia, due to the 2021 flooding. The picture you see here is actually an initial rendering of the project and what it would look like once it's completed. The last project at the bottom here highlights the widespread adoption of this technology with the first 3D printed office built in Dubai by a Chinese company called Winson. Dubai ambitiously aims to make 25% of all its new buildings using additive construction by 2030. And just from these projects, we can see the innovative potential additive construction holds. And on that note, I'll pass the mic off to Daichi to discuss bio-based prefabricated and modular housing solutions.
Great, thank you very much, Riva. Yeah, so I'm going to be going through the sort of second technology that we wanted to evaluate, which is this concept of prefabrication or modular housing. It's sometimes also called off-site construction. I'll be going through some of its benefits and opportunities for growth, as well as some of its bio-based applications, and then an opportunity here in BC for bio-based construction. There we go. And so prefabrication is an alternative to traditional construction where rather than the traditional stick building construction where you bring all of your materials like timber and cement and insulation to the site to be built, you prefabricate these materials in a central location in a factory. And so it can be anywhere from a wall all the way to an entire unit like the one shown in the picture here. And these are built, or these are brought all the way to the desired site and constructed. And the idea here is that by pre-building it in a factory, you can reduce a lot of the time and costs that are associated with traditional construction. And so before we get too far into it, as a little appetizer, I did also want to share a couple of short video clips. And these are from a video tour of a house that was presented at Dutch Design Week 2021, which took place just last October in Eindhoven, Netherlands. And it's just a really good example of how bioproducts and modular housing can work hand in hand. So I'll let this very charismatic host who was involved in the creation of this house introduce the concept.
Building methods, circular building methods. What you can see a house is built out of wood, but modular. So that means that we put it in the computer, we phrased everything, it came out of the factory like this, then we build it like Lego blocks, chick, 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 in a few days, and you have a whole house. And the cool thing is you can make it smaller or bigger. You can take everything apart and build it out somewhere else again. So that's the idea. If you want to build sustainable, you have to build modular and with wood. So also in the future, people think sustainable is going to be more expensive. No, when we do it out of the factory, it's actually cheaper and it's better. And third of all, I promised you 100 bio-based materials. Well, we put them in different rooms with different teams, and I suggest that we go inside now, right? Let's go.
Yeah, there we go. So that's the idea behind this house. It was built with this idea of sustainability, circularity, and modularity in mind. And as you mentioned there, they used over 100 different bio-based materials throughout this house. And unfortunately, we don't have time to show all 100 of these, of course, but we'll jump forward a little bit in this video just to show a quick example of some of the materials that they did utilize. So here we go.
Let's go to fungi and bacteria. fungi, mycelium. I don't know if you heard of it. Mycelium is the roots of the mushroom that bind together. They make this light but incredible structures. For example, look at this. This is our wall made out of mycelium. You can't touch it now because you're on camera, but this looks, oh, this feels so great. It's super light, it's water resistant, it's fire retardant, and it's acoustically amazing. That's why they make a lot of acoustic shields, but you can also make it as insulation. This is an insulation wall made from mycelium. So you have them in patterns, you can use them immediately in your house. They are very, very good. And if you don't need them afterwards, you can crumble them, throw them in the earth, and they're very good as fertilizer. Now, look at the floor. The floor is biocomposite and mycelium as well. So acoustically, insulation-wise, super. We have also a table, 3D printed from mycelium. We have a lamp from mycelium. But the craziest thing here in this room, except for me, is the wall. Because this wall is made out of concrete made from bacteria. So you don't need the cement, which is very bad for the environment, we all know. You make concrete with bacteria. The bacteria crystallize the stones so that they have the same effect as concrete, but it's the bacteria who do it. So the bacteria make sure that all the stones, you have a lot of stones, the bacteria crystallize them, make them very hard, but if you don't need them afterwards, you can actually take them apart way more easy than normal concrete. So this is revolution.
There we go. So those are just a few examples of a lot of the really cool concepts that they were able to build into this house. And I think it's a really good example of what we can work towards here in BC as well. And the rest of the video is very interesting, so I would highly recommend checking it out, if not just for this guy that's talking us through it, because he's an amazing host. So with that, I'll briefly go over its benefits in order to understand why this technology is being considered as an alternative to the traditional construction methods. And so one of the really important advantages of this technology is its ability to be assembled and disassembled quickly and easily. And this allows for construction projects to be built more circular and with reuse and recycling in mind. And this kind of builds on what he said in the video about being able to build like Lego bricks. Obviously, it's not quite as simple as Lego bricks, but this does increase the circularity. And by designing these modular buildings with reuse in mind, a lot of these downstream issues that Braden mentioned earlier, such as the difficult separation of construction waste after demolition and the landfilling and the need for open pit burning can all be avoided. And then the quality and consistency of these prefabricated parts is generally higher since they are built in a controlled environment in a central location in a factory. And this allows you to avoid a lot of the variables and risks that can come with building on a traditional construction site. But what this quality and consistency does is it usually promotes a tighter seal for these houses and buildings. And this increases the overall energy efficiency of a building. And this, of course, reduces the carbon footprint. And then similar to additive manufacturing, as Riva mentioned, the material waste or the excess material in prefabrication is generally lower than traditional construction, since again, you're building in a central location and all of the parts are, the dimensions of the parts are all predetermined. And so if you do have excess materials that are cut, you can push it towards the next project, or it can be recycled and reused a lot more effectively. Whereas in traditional construction, usually it would just be thrown away after the project is complete. And then, as I mentioned earlier, the construction time and labor requirements are generally decreased. And this is because the process is a lot simpler when you just have to assemble a few pieces. And what all this adds up to is that, in theory, prefabrication is a lot more cost-friendly alternative to traditional construction. Now, of course, there are some external factors that can determine whether it is truly more cost-friendly, but I'll touch on this in a bit. But a lot of these benefits are especially crucial when talking about remote communities, whereas Braden mentioned a lack of skilled laborers is sometimes an issue. And so if you can simplify this process, it can make housing a lot more accessible for these communities. And then this design for reuse principle, of course, decreases the need for the landfilling and open pit burning that he touched on as well. And so prefabrication is a fairly new concept in construction. So as it develops further, there are some opportunities for growth, similar to additive manufacturing. One unique to prefabrication is the public perception. And often they use standard preset looks, which to some people can look dull or boring. And since they're built so quickly, often people assume that they're unreliable or of a lower quality than a traditional house. And this can lead to the houses that are built using this method to sell for a lower price than a traditional house. And so, of course, for construction companies and builders, even though the building itself costs less to make, if you can't sell it for as much, you don't get as much return on investment. And so that's one of these external factors that I was alluding to earlier. Another limitation is the flexibility of this building method. Of course, you're working with these predetermined dimensions, and so it is difficult to customize a house to the needs of a client or of the build site. And so so this can make it a little bit more difficult to build with this technology. And then this also applies to the planning phase and the construction phase itself. So if any issues come up during construction, it can be difficult to adapt. Finally, another limitation is the transportation. Since you're working with fairly large pieces, the bigger the piece is, the harder it can be to transport it to areas. And this is especially difficult for remote areas, of course. There are some opportunities, of course, for this to be improved, such as using smaller prefab elements to make them more accessible to these communities, or setting up suppliers within these communities themselves. And so a lot of these opportunities can be realized as the adoption of this technology increases, if a balance can be struck between the flexibility and the convenience, and different options can be developed to suit the unique needs of different build sites. And so with that brief overview of what prefabrication is and its benefits and opportunities for growth, let's move into some of its bio-based applications. As Braden touched on earlier, bio-based elements in housing are very beneficial, as they not only improve the sustainability and the circularity of a building, but they can also have a benefit to the health and psychology of the residents within the building. And there are many examples of the innovative use of biomass to produce construction elements. And the house we saw in the video earlier is a really good example of this. This picture on the right here is a zoomed out view of that house. And as they mentioned, the house included over 100 unique bio-based design elements, many of which are modular, utilize waste materials, and are designed for reuse. We saw some of the applications for fungi and bacteria, like that bacterial concrete, which can reduce the need for cement. But some of the other biomass sources that we didn't have the time to show include local sources of earth, like dirt and rocks and gravel that you can use to build bricks and garden beds. And then, of course, with any bio-based building, the wood is a very important structural component. But another unique thing they did was they used burnt wood, you can see here, which they claim improves its external barrier properties, which is something I hadn't seen before. So I thought that was very interesting. They also used agricultural residue, such as straw insulation and hemp plaster boards. And of course, wherever there are humans, there's always going to be food and sewage waste. And so they showed some of the valorization opportunities for these materials as well. And what all of this shows is that the opportunity to valorize these biomass sources is there, and it is technically feasible. It's just going to be a matter of recognizing what biomass sources we have here in BC that can be sourced locally, consistently, and sustainably. And this is something that the creators of this house also emphasized, is this need to source your biomass locally and sustainably, since this can, as Riva mentioned, not only reduce the transportation needs and the costs and emissions associated with that, but these local sources of biomass are also more likely to be adapted to the local environment. And so you can take advantage of these natural characteristics and resistances to increase the quality of a build. And so in order to allow for this innovation, it is going to be important to develop building codes with this in mind to ensure there's space for this kind of innovation. And so finally, throughout the course of this project, we were able to get a look at the general landscape of construction companies in BC and in Canada and around the world. And what we noticed is that it is fairly evident that the industry, at least in the traditional stick building sense, is a fairly mature industry and line up with some of these indicators of a mature industry in a typical industry life cycle. And what this usually means is that it may be heading towards a decline phase. However, this does open up a door for an emerging solution to come in and revamp the industry. And that's where bioproducts and these innovative technologies like additive manufacturing and prefabrication can come in. And so there are some indicators of this emergence here in BC, including the growing interest in the research of these products, including some research taking place here at BPI, such as fiber reinforced concrete, And this is a great first step towards filling the space, but there is still a fairly significant opening for construction companies to take advantage of this opportunity in BC for bio-based solutions in construction. One company I did want to highlight is the B Collective. They could be considered early adopters in bio-based construction, and they're a company working specifically in prefabricated bio-based construction. But what differentiates them from some of the other early adopters is that they're working towards establishing a standard and a precedent for bio-based prefabrication here in BC. And they're doing this by taking advantage of an open sourced approach. And the goal for them is to make net zero construction and bio-based prefabrication easier to adopt for other companies by focusing on collaboration and shared knowledge rather than strict competition. And so with this completely free, excuse me, this completely free open source system, as these new companies start popping up and wanting to work in the space, they can draw from this knowledge base and add their own experiences to it. And this will go a long way towards establishing a new industry standard. And finally, Riva did touch on this earlier, but it is important to recognize that with any new or innovative technology that's emerging within a mature industry, there's always going to be some initial resistance and difficulty in finding reliable information and standards to work off of. And this problem is, of course, only magnified when you're talking about using these innovative bio-based products. And so these companies like B Collective, who are actively trying to make these technologies more accessible, and these many European companies that we've shown today that are working in the space that we can draw inspiration from, are going to be key in not only helping to revamp this industry, but also to reshape it for a more circular future. And so with that, I'll pass it off to Annie, who will wrap up the presentation by discussing some of the main hurdles and gaps that need to be overcome in order to understand and implement these technologies. So take it away, Annie.
Awesome, thank you, Daichi. So far in the last couple of sections, we discussed on the urgent needs in remote housing, explored the benefits of bio-based housing, and an overview of the current technologies and processes that can address these needs. Now that we're gearing up for the final section of today's webinar, I will be discussing the policies and building codes, life cycle and social impact assessments, waste management, and finally, the gaps in research. As we presented the potential solutions to support sustainable construction for remote housing, it's important to pay attention to the hurdles that can pose a great challenge for widespread implementation. First, looking at the building codes that we have in British Columbia. Although we have quite an extensive building code system, there are still areas deeply lacking frameworks and requirements for bio-based materials and technologies. This issue with policy is also magnified in First Nation communities. And finally, an area of improvement on the policy side is to encourage more eco-labeling initiatives for bio-based construction materials. So looking into life cycle assessments, they can be a helpful tool to understand how carbon emissions are tracked from the beginning of the cycle all the way to the end. However, there are significant shortcomings with the conventional life cycle assessment studies on bio-based materials. Typically, these assessments are studied in a linear fashion where the end of the analysis stops at waste. However, there needs to be an attempt to incorporate the waste right back into the beginning of the cycle to help achieve circularity. Another issue with life cycle assessments is that there are differences in how these assessments are conducted, and this can cause a great degree in variances and inconsistencies when trying to determine the carbon emissions on bio-based materials. Moving on to waste management. The waste management systems still face a number of challenges in moving towards a circular system. There are limitations in tracking and monitoring construction waste, and this can cause difficulty in trying to get an accurate picture of the scale and quality of waste. Further research is needed in this area to help find a way where waste repurposing technologies could be implemented in construction. Finally, looking into the opportunities in research, further research needs to be conducted on bio-based materials and their effectiveness, particularly regarding 3D printed homes. There needs to be an additional evidence that they can be durable and resistant to molds, and thorough testing of novel housing materials and technologies will help in accelerating adoption by the building code system. As well, in general, within BC, there's a lack of relevant sustainability literacy among building professionals, which is intensified in remote communities. Efforts need to be made to support and develop community training that could help establish bio-based housing in remote areas. So with the question that we have kept in mind while we did our research for this project is how can we enable the adoption of bio-based materials in housing? And the conclusion we've come to is that in order for the solutions that we have discussed today to be implemented, there are 4 key areas that can make this challenging. These areas are of policy, funding, infrastructure, and research. And so we've analyzed this a little deeper and put together some takeaways under these 4 areas. On the policy side, building codes and zoning laws need to be amended to allow for new and innovative technologies such as additive manufacturing and modular housing to be implemented, and as well improve standards for labeling of bioproducts. For funding, there needs to be more support for further subsidies and incentivization for bottom-up adoption of bio-based materials. As well, with the current funding structure for sustainable social housing, particularly for First Nation communities, this process is quite complicated. There needs to be a more accessible and simplified way to get funding for sustainable development. With infrastructure, we hope to see more infrastructural support, including segregation and sorting activities for remote regions to take advantage of recycled construction materials. Regarding the innovative technologies such as 3D printing and modular housing, we would like to see more infrastructural support in remote communities. As well, within the community, support is needed to train and increase the skill set for sustainable building professionals in remote areas. And finally, standards should be set with a focus on the identification and promotion of the use of local bio-based material feedstocks. In research, valorization of construction waste is the overall goal, eventually hoping to replace traditional materials with sustainable options. There needs to be a standardization of life cycle assessments and social impact assessments of bio-based materials. As well, further research into bio-based material effectiveness is needed, and investing in this area can help close the gaps in knowledge and research that could ultimately help in accelerating the transition to bio-based housing. This takes us to our final slide for today. And what we hope to see is a more sustainable and innovative approach to the future of construction, and along with the implementation of bio-based materials. We hope that technologies such as additive manufacturing and modular housing will help construction transition into a more circular industry. We would like to thank everyone again for everybody's attention to attending our webinar. And we would also like to thank again the Ministry of Forests, Lands, Natural Resource Operations, and Rural Development. Thank you.